So we're going to be talking about the derivatives of polynomial functions. So we basically already learned that a derivative helps us find the rate of change of the tangent at any specific a value on a curve. Hence why this would probably be the easiest thing to do your test on, but because the test is based on limits, even if you use derivatives, I will probably not take that answer. You can use derivatives to help you find your answer, just to double check if it's right, but you cannot write your solutions in terms of a derivative. Okay, so you can use derivatives to check your answer, but you cannot use derivatives as your solution. All right. So there are several rules that greatly simplify the task of differentiation. So limits is a way of differentiation, except it's a very tedious and long way of doing it. So we have some basic rules. So the constant function rule. So if f of x is equal to a constant, then the derivative of f of x is equal to 0, or d over d of x of k is equal to 0. I'm probably going to ask very few questions during this, so if you don't want to answer, that's fine. If it's an easy answer, feel free to answer. So the derivative of any constant is going to be 0. So f of x is equal to 0. F prime of x, y, derivative of y is equal to 0. And the derivative of d over dx of 3.9 is equal to 0. Or in other words, we have dy over dx is equal to 0. Does anyone know why the derivative of a constant is 0? I'm going to plot in f of x is equal to 7. Priyanshu?
There's no rate of change.
There's no rate of change. If I were to ask you to find the instantaneous rate of change of f of x equal to 7 at the point 2, it's going to be 0 because it's just a horizontal line. So a constant means the instantaneous rate of change, or IROC, is always 0. So that's the first rule. Now comes the power rule of a derivative. So derivative is pretty easy. It's just a set of rules to help you find the rate of change or find the slope of the tangent at a specific x value without having to go through the hassle of doing limits. So if f of x is equal to x to the power of n, where n is a real number, then the derivative of f of x is equal to n times x to the power of n minus 1. So basically, your n becomes your coefficient, and you just subtract 1 from the exponent, and that becomes your derivative. So for example, the first one, f prime of x is equal to, bring the 12 into the front, and then subtract 1 from the exponent. So you get f prime of x is 12x to the 11. We get h of x is equal to 1, because if we look at the basic graph of y is equal to x, my slope is 1, which means that my instantaneous rate of change at any x point is always going to be 1, which means I can therefore say that the derivative of x is going to always be 1, because it's always going to be the instantaneous rate of change. Now the next one, y prime is equal to 5 over 2 times x to the power of 5 over 2 minus 1, which gives us 5 over 2x to the power of 3 over 2. That would be my derivative. And obviously, to find the instantaneous rate of change at a specific x value, you would just plug in your value for x. So if x was equal to -1, plug in -1 to your derivative, and that will give you the instantaneous rate of change for that curve at that specific x value. Now we have y is equal to the cubic root of x, so you can easily just write this as a exponent of x to the power of 1 over 3. And I get my derivative is 1 over 3x to the power of negative 2 over 3. But because we don't like negative exponents, this can also be written as 1 over 3x to the power of 2 over 3. So are you guys starting to realize how derivatives could have made your lives easier in this first test? Not bullying. Because they want you to suffer for a bit and then get to the easy stuff. See, instead of writing, limit this, limit that, I can just take the derivative, plug in my x value, and call it a day. Which is why I said you can check your answer using the derivative, but you cannot use it as your answer. No. So then we have g of x is equal to 1 over x to the power of 4. So we can just turn this into a negative exponent by bringing the x and the exponent up. So we get g of x equal to x to the power of negative 4. So we can take our derivative of g of x is equal to negative 4 x minus 5, or negative 4 over x to the power of 5. Depending on what the question is asking, one of them is going to be easier to do than the other. I can see all the complaining in the chat. Imagine being able to find the rate of change of that snowball in just one step. If only you were allowed to use something that was so easy. I'm just gonna have fun with this lesson because you guys are just like feeling the pain right now. You're like, why am I writing this test using 8 lines and killing trees and wasting paper when I could have just written my answer in 2 lines? And now we have the constant multiple rule. So we have if g of x is equal to k, which is a constant, times the function, then the derivative of g of x is equal to k times the derivative of f of x. Okay, so the first one we have is h of u is equal to 2u cubed. So I can just find the derivative by leaving my k, which is my 2 by itself, and then taking the derivative of u to the power of 3, which is 3u squared. And then I can expand the 2 into the coefficient in front of u squared, which gives me 6u squared. Which means that my derivative of h of u, should be brackets here, is 6u squared. And we're going to take that same concept with the next one. So we don't like roots. Roots are ugly and are hard to work with. So we just rather turn into exponent. So I can change this to 6 times x to the power of 5 over 2. Which means that I'm going to use my constant multiple rule. So y prime is equal to 6, leave it alone, of 5 over 2x to the power of 3 over 2. I take my 6 and multiply it by 5 over 2, which gives me my derivative of 15x to the power of 3 over 2. And then last but not least, I have y is equal to 2 to the negative 3. Remember, we don't like negative exponents, so bring the x to the negative 3 up to make it positive. So now we get y prime is equal to 2 times 3x squared, which gives me a simplified expression of 6x squared. Yes, Priyanshu.
So is this rule kind of like properties of limits?
It's the properties of limits except with derivatives.
Okay.
So properties of limits mimic this, except with limits you have to write like 5,000 lines. As you can see with derivatives, you write 2 lines and you get the same answer. Okay. Now we have the sum and difference rules. So if both functions p of x and q of x are differentiable, and f of x, then f of x is equal to p of x plus and minus q of x, then f prime of x is equal to the derivative of p of x plus or minus the derivative of q of x. So what you're basically doing is you're taking the derivative of each individual term in your function. So what this looks like, again, we don't like the roots, so we get f of x is equal to 4x to the negative 5 minus 3x to the 1/2 plus pi x cubed plus 2. So my f prime, again, we follow our rules from the beginning. When you bring the exponent in front of a coefficient, you have to multiply it. So you would have to, so the derivative of 4x to the negative 5, you take the negative 5, multiply it by the 4, so you get negative 20x minus 6, because you're always subtracting 1, minus 3 over 2x to the power of negative 1/2 plus 3 pi x squared. And because we have a constant at the end, we do not have to worry about that. There's no derivative for a constant. It is just 0, because the rate of change of a constant will always be 0. So now we have some more examples of these derivatives. So what we're going to do first is we need to simplify and then differentiate. So by simplifying, you are just going to expand, bring it into a simplest form, and then take the derivative. Okay, yes, Madge? Yes?
Can you just pull it up just a
Okay.
little? I just want to copy the top. Yeah, just a minute.
Oh, because it has pi in it, and you have a question with pi. So is the conclusion I'm going to hypothesize that everyone is currently checking the answers that they got using derivatives now to check if they're correct. Who is currently doing that, checking to see if their answer is right using the derivative? Is anyone doing that right now? Yeah, no, you guys are just gonna hate it because it's literally gonna take 20 seconds to figure it out. So again, we have our first example, which is root x minus 4 times 2 root x plus 6. Okay, thank you, Saad. Okay. Oh, you guys handed it in. Damn. Got some fast people. As you guys can see, I think the first person who handed it in, I think already gave back their assessment. So yeah, and for those of you who've had me already, it's hard to mark online, but I will always comment and tell you where I've taken a mark off. So I think I have 5 of you. So I know, I think Joel, Anna, who else was in my class? Leanne, and and Sam. They all know that I actually tell you where you've gone wrong and why I take marks off. So now I'm going to expand and simplify. So if I expand this, I get I get 2x minus 8 root x plus 6 root x minus 24, which simplifies to 2x minus 2 root x minus 24. Or, because we don't like roots, 2x minus 2x to the power of 1/2 minus 24. And now it makes it easier for me to find the derivative. So we're going to use the sum and difference rule. So So I'm just going to take the derivative of each. So y prime is equal to 2 minus 2 times 1/2 x minus 1/2. This doesn't matter because the derivative of a constant is 0. And this, when we simplify, is equal to 2 minus x to the negative 1/2, or which equals 2 minus 1 over the square root of x. Now what I can do is I need my common denominator. So it's going to be root x. So I get root x times 2 root x minus 1. And because we don't like radicals on the bottom, what do I have to do to make this look nicer? So what would I have to do to make this look nicer? Remember, we never like radicals at the bottom. You're going to do the conjugate, so we're going to multiply by root x over root x. And this gives me my derivative of 2x minus root x over root x. So this would be my derivative. So now my next one, I have root x minus 2 over the cubic root of x. So again, we want everything to look nice. So we're going to bring my cubic root of x up and make my exponent negative. So I get x to the negative 1 over 3 multiplied by x to the power of 1/2 minus 2. So now I have to distribute my x to the negative 3 into my brackets. So remember, guys, exponent rules, exponents with the same base. We have to add my exponents. So I have to add negative 1 over 3 and 1 over 2. So that gives me x to the 1/6 minus 2 times x to the negative 1 over 3. And now, because of the sum and difference rule, I can take my derivative, which is 1 over 6, x to the power of negative 5 over 6, minus 2. We're going to use our constant multiple rule. I just did the constant for now, which is negative 1 over 3x minus 4 over 3. So that's the derivative of x to the negative 1 over 3. And now I can just simplify, which gives me 1 over 6 x to the power of 5 over 6 plus 2 over 3x to the power of 4 over 3. I just brought my exponents to the bottom to make them both positive. So is everybody okay with this right now? Ah, yes, 2 for 2. People are handing it in one file. This is what I enjoy. So as you can see, finding the derivative is easy because I can ask you a question. Given the function y is equal to root x minus 4, 2 root x plus 6, what is the slope of the tangent at the points negative 2 and 3? Then you would just take the derivative, and at the end you sub in negative 2, and it would give you the slope of that tangent. Yeah, Saad, you did it correctly. You have all the questions here. I'm just looking at them right now. So you're good. Okay. Next page, we have the position s in meters of a moving object after t seconds is defined by the function s of t is equal to t plus 2 all squared. You want to find the velocity of the object after t seconds. So what I need to do first is I need to find my v of t, so my velocity, which means just taking the derivative of s of t. So I got to expand t plus 2 squared, which expands to t squared plus 4t plus 4, which means my derivative becomes, so s of t, or s prime of t becomes 2t plus 4. So I can just write that over here. And because I'm finding the velocity at 3 seconds, I have to sub in 3 for t. So my v of t is going to be v at 3 is equal to 2 times 3 plus 4, which is equal to 6 plus 4, which gives me a velocity of 10 meters per second. And example 3 on this lesson is going to really help you guys check your answer for those curve questions. When is my, or what is the rate of change, or what is the rate of change, or what is the slope of the tangent at this point? So example 3, we have find the equation of the tangent line in standard form to the curve y is equal to x5 at the point -2 and -32. So what you guys would be doing on the test right now, which is very annoying, is doing f of h minus 2 minus f at -2. It's going to take you guys around, 5 to 10 minutes. If your hand doesn't hurt, if your hand hurts, it'll take you longer. But derivatives solves this problem. So we have to find, in order to find the point, the equation of the tangent or the slope of the tangent, we just take the derivative of y. So y prime is equal to 5x to the power of 4. So now what I have to do to find the slope of the tangent is find y prime at x is equal to 2, which gives me 5 times -2 to the power of 4, which gives me 5 times positive 16, which gives me 80, which implies that the slope of the tangent at x is equal to -2 is going to be 80. Okay? And now we can use that information to find our equation of the tangent in standard form by using y minus y1 is equal to m times x minus x1, using the points -2 and 32. So I get y minus -32, which is y plus 32, is equal to 80 times x minus -2, which is plus 2. So we get y plus 32 is equal to 80x plus 160. I want to move everything to one side, preferably where the x is positive. So I'm going to move everything to the right side. And this is going to give me 0 is equal to 80x minus y plus 128. So how do you guys feel about not being able to use this on your test today? Betrayed? I didn't even betray you. I was just merely introducing you to a very long way of doing stuff. Yep, one page. I told you guys, one page of work down to 2 lines. I did have the secret, and once I knew we were doing derivatives next, I'm be like, my class is gonna hate me for making them do limits on the test. Oh look, another example that won't take us a page. So find the coordinates of the point where tangent to the function of y is equal to root of 16x cubed is parallel to 12x minus 2y plus 1. Oh my gosh, this looks like question number 8 or 7 on your test. Wow. So what do we have to do first? We have to find the slope of the guy in standard form. So we get 12x is equal minus 2y plus 1 is equal to 0. Move the 2y over to the right. So my equation becomes y is equal to 6x plus 1 over 2. So, which means that our slope has to be 6 because we want the equation of the tangent line to be parallel to the line 12x minus 2y plus 1. So, we have our function y is equal to root of 16x cubed. I can just divide this perfectly by taking the root of x times the root of x plus 3, or x cubed. And I'm left with 4 times x to the 3 to the 1 half, which gives me 4x to the power of 3 over 2. And now what I can do is use my constants rule for derivatives, is take y prime is equal to 4 times the derivative of x to the power of 3 over 2, which is 3 over 2x to the power of 1 half, which gives me 6 times 3, 4 times 3, which gives me 12 over 2, which gives me 6x to the 1 half. And because I know my rate of change is 6, I can just set 6 equal to my left side, which means that I can find the x-coordinate of where the slope of the tangent is going to be 6. So now I can divide both sides by 6. They cancel out. I'm left with 1 is equal to x to the power of 1 half, or root of x. To get rid of that square root, I just square both sides. And I'm left with x is equal to 1, which means that my point of tangency is going to happen when x is equal to 1. So now what I have to do is sub in 1 to my original equation. So I'm going to sub in y, where x is equal to 1, which is equal to the root of 16 times 1 to the power of 3 is equal to the root of 16, which is equal to 4. So now my point is 1 and 4, which means that the point where the tangent to the function y is equal to 16x squared is parallel to that line is at the point 1 and 4. So this is where the slope is 6. So, pretty easy. Okay, people are crying, that's fine. I will never make you guys do a limit ever again after this. Okay, and then we have one final question for this lesson, which is it might be a long one, probably will be. So we want to find the equations of both the tangent lines to the parabola, y is equal to x squared plus x. That passes through the point P of 2 and negative 3. So my point 2 and negative 3 is going to be all the way down here. So, as you can see, just by looking at the graph, the first time this is going to hit a tangent point going this way is going to be around this. But I need to algebraically find, using derivatives, that is going to be the point that it hits. And the other one is going to be somewhere up here. We don't know where that's going to be. Okay? So there's going to be 2 points at where we hit the parabola. There's going to be 2 tangent points where we hit the parabola from the point 2 and negative 3. So we have our point 2 and negative 3. We have my point here, which we can label as A, because I don't know what A is. And whatever that A value is, I have to sub it into x squared plus x. So A and A squared plus A. Okay? The reason why The reason why the right side is a squared plus a is because I'm evaluating the function to see if there's a tangent at that specific, we're using that specific function. Remember, x is equal to a. That's what we learned from limits. So which means that my slope, so we're going to use this as x1, y1, x2, y2, which means that my slope is going to be m is equal to y2 minus y1, so a squared plus a minus negative 3, which is plus 3, all over x2 minus x1. Okay, so this is what we're going to be using for this example. So again, if you're not paying attention and focusing on your test or assignment, sorry, that's fine. You can go back to the videos and listen to it after. So what we have to do first is I need to find my derivative of my function. So we know my function is y is equal to x squared plus x, which means my derivative is going to be 2x plus 1. And because we always use a for our tangent points, remember subbing x is equal to a, we can also say 2a plus 1. So this is going to help us find the points at where those lines hit our function. So I'm going to set 2a because that's going to help me find my slope. That is the slope of the tangent. I'm going to set it equal to y2 minus y1 over x2 minus x1, which is equal to a squared plus a plus 3 all over a minus 2. Now what I can do is cross multiply to solve. So we're going to solve for a. So I get 2a plus 1 times a minus 2 is equal to a squared plus a plus 3. I'm going to FOIL in or factor, distribute my binomials, and I get 2a squared minus 3a minus 2 is equal to a squared plus a plus 3. Now I need to move everything over to one side. So preferably let's move my right side to the left side. So I get 2a squared minus a squared minus 3a minus 4a minus 2 minus 3. And that all equals to 0, which means I get a squared. But I put 4a, it's just a. A squared minus 4a minus 5 is equal to 0. And as you can see, we have a quadratic, a squared minus 4a minus 5. If we were to factor that out, guys, what would my two binomials be in brackets? Sum of the negative 4, product of negative 5. So we get x plus 1 and x minus 5. So we got 0 is equal to x plus 1 and x minus 5, which means the possible x values where it's going to pass by the curve, where the tangents hit the curve, is going to be at a, sorry, this should be a, at a is equal to negative 1 and positive 5. So now I need to see what my y values are. So I'm just going to sub in negative 1 and 5 to my original function. So a squared plus a. I'm going to solve for y, where x is equal to 5. And that gives me 5 squared plus 5, which gives me 25 plus 5, which gives me 30. So my first point is 5 and 30. That's where my tangent line is going to hit the curve at 5 and 30. So Madge, when I moved, this is a mistake, by the way. It should just be a by itself. So when I move this positive a over to the left side, I get negative 3a minus a, which becomes minus 4a, or Muhammad, sorry. And now I have to do the same thing, find y where x is equal to negative 1. So I get negative 1 squared plus negative 1, and we all know that that equals 0, which means that my other points where the tangent hits the curve is at negative 1 and 0. And if you guys notice that we visually showed that. We're just trying to verify that it was true. So now I have to find the slope of the tangent, which means I have to sub my a values into my derivative to find the slope of the tangents. So I'm going to find the slope of the tangent where x is equal to 5 using my derivative, which is 2 times 5 plus 1, which is equal to 11. So this is my slope on my first tangent where x passes through, where the tangent passes through 5 and 30. And then I got to find the slope of the tangent where x is equal to negative 1, where a is equal to negative 1, which gives me 2 times negative 1 plus 1. And that gives me a slope of negative 1. So now what I can do to find the equations is I have all of my information. Remember the slope of 11 at the tangent corresponds with the points 5 and 30. And the slope of negative 1 corresponds with negative 1 and 0. So now I can find my equations in standard form. So I get y minus y1 is equal to m times x minus x1, which is equal to y minus 30 is equal to 5 times 11, that was my mistake. Which is 11 times x minus 5, which gives me y minus 30 is equal to 11x minus 55. I'm going to bring it over into standard form. So I get 0 is equal to 11x minus y minus 25, which is the slope of my tangent when my tangent hits the curve at 5 and 30. And now for the next one, I get y minus y1, which is just y minus 0 is equal to negative 1 times x minus 1, x minus negative 1, which is x plus 1. And that is going to give us y is equal to negative x minus 1, which gives me 0 is equal to x plus y plus 1. I just move all of my terms from the right side over to the left side.